Hello everyone, welcome to the lecture series on foundation engineering. In this video, we are going to see about shallow foundation, particularly what is shallow foundation and its types. If you happen to divide a structure into two parts, you can categorize into superstructure and substructure. Now, what is a superstructure? Those that lies above the ground surface is what we call it as a superstructure, and that part of a structure that lies beneath the ground surface is called substructure. Obviously, the foundation is a part of substructure. If you classify a structure, it can be categorized into load-bearing structures and framed structure. In both the cases, whatever be the mechanism of load transfer, ultimately the load will reach the foundation and it will be distributed to the soil. Hence, the foundation and the mechanism of transfer play a very important role. To understand this better, we are going to learn a lot about that in this particular subject. The purpose of a foundation is to transfer the load from the structure to the soil and distribute it evenly and safely, and also to hold the structure firmly into the ground surface such that even under lateral loads the building will not move, and also it prevents the building from overturning due to the excessive lateral forces. It gives a level surface for the construction of the superstructure. What is the criteria for a proper foundation design? There are two major criteria. One is the structure should not fail by shear, and the permissible settlement criteria should be satisfied. That is, the settlement should be within the safe limit. You are constructing a structure over which you are adding the load, and also it will have the self weight. There is some point where the soil cannot withstand any further load and it will fail. That is the shear criteria. And also, if you load the structure excessively, the structure entirely will tend to penetrate into the ground surface. You should ensure that your structure is not getting failed by any of these two criteria, and that is the part of our design. Foundation can be broadly classified into two types. One is shallow foundation, another one is deep foundation. As per Terzaghi, if the ratio of depth to width of the foundation is less than or equal to 1, then it is called shallow foundation. If the ratio of depth to width greater than 1, then you call it as a deep foundation. This may not be true all the time, but this is the initial rule that has been used for the classification. That is, let us say this is our foundation. This is the depth of the foundation and this is the width of the foundation. If both values equal or the ratio is less than or equal to 1, then you call it as a shallow foundation. And if it is going beyond 1, then it is deep foundation. To have a better understanding, let us imagine a scenario that there is a structure. One is a 2 BHK single story flat. Another one is a skyscraper like a Burj Khalifa. Do you think that the foundation for these two structures will be the same? Obviously no, right? The structure which is a skyscraper will have to transmit excessive amount of load through the foundation to the soil. So for such situation, when the load to be transferred to the ground surface is heavy, and if the soil stratum is not good enough to bear the load, then you may have to transfer it to the stratum that is firm enough to transfer the load. So in such situations, you will go for a deep foundation. If the load to be transferred is relatively lesser, and if the soil stratum is also firm, then you can go for shallow foundation. Let us discuss about the different types of shallow foundation one by one. The first in that is a isolated footing. In framed structure, where the column is involved in transferring the load, you will be having an individual footing beneath every column. So in such situations, this footing can be provided with either masonry or with the help of concrete. Remember, if masonry footing is provided, you are supposed to provide steps such that the foundation area, the stress developed are within the permissible limit at the base. See this figure. This is the individual column, and beneath every column you are having a footing. And as I told you, if the load to be transferred is heavy, to bring the stress developed within the permissible limit, you will be developing stepped footing. And also you may also create this inclination with the help of a slope instead of a step also. In the case of a load bearing structure where the wall is involved in transferring the load to the foundation and then to the soil, the entire length of the wall is involved in transferring the load, right? So the footing also should extend to the entire length of the wall. In such case, you may go for something called a strip footing, where the footing is extended to the entire length of the wall. Since this is extending to the entire length of the wall, this can also be called as a wall footing. And see here, just like a isolated footing, the strip footing can also be having a steps where the transferring of the load and distribution of the load is important. See here, this is the next type of footing called combined footing. Say for an example, the two columns in a structure are very close to each other. If you try to provide two isolated footing, there may be a overlapping of the footing area, right? So in such situations, you may have two different columns and the footing for those two columns are common. So this is what we call it as a combined footing. This is more useful when two columns are very close to each other. See here, this can be of two different shapes. One is rectangular combined footing, another one is a trapezoidal combined footing. This is column 1 and this is column 2. If the column loads are almost equal, then you can go for a rectangular combined footing. And if this is different, where this column 1 and column 2 loads are differing from each other, then you can go for a trapezoidal combined footing. The next one is cantilever footing. These may look same, but the cantilever footing is very much different from a combined footing. How? Say for example, there is a plot in which you are doing a construction. You are not giving any offset. For the sake of wanting a very big structure, you are extending your construction until the extreme end of the plot. But your neighbor is also doing the same. He may also want to build a structure that is very big. What will happen? Let us say both of you are having a column at the extreme ends. If you create a footing for this column, there are situations where this may overlap or your footing may extend into the property line of your neighbor. So in that situation, if you want to transfer the load from an exterior column to an interior column, you may connect them with the help of a strap beam, which will act as a fulcrum, and the interior column will helpful in balancing the load of the exterior column. Then you call it as a cantilever footing. As I told you, this will be very much useful if you have a boundary line, property boundary line issue or an eccentric loading conditions. This cantilever footing will be much more useful. Often people are getting confused with cantilever footing and a combined footing. Know that those are entirely different ones. This footing is called as a continuous footing. This may also look like a combined footing, but it also is slightly different from a combined footing. See here, the number of columns are more, which means if the entire row of columns are connected by a single footing at the bottom, then you may call this as a continuous footing. So where this will be useful? This will be much more useful in the case of a differential settlement and to safeguard your structure against seismic loads. What is differential settlement? One end of the structure will be settling much faster when compared to the other end. There won't be any uniform mode of settlement there. In such situations, you can go for a continuous footing. The next type of shallow foundation is a raft or mat foundation. When the load to be transferred is very heavy, even the soil is also not suitable to bear such kind of load, then you may go for this raft or mat foundation. Let us say that there are totally a 9 number of columns. Usually in such situations, when the load to be transferred is heavy and the soil is also not suitable to take such heavy load, we will usually increase the size of the footing. Likewise, we are creating isolated footing for the entire set of columns. here also for the other columns. Likewise for these two columns. Now I'm trying to calculate the length and width of all the individual footings and I am adding them together. If the sum of the base area of all the footing required to support the structure exceeds half of the total building area, then it is preferable to go for a single concrete mat that will withhold the entire structure, which is called a raft or mat foundation. See here, for all the columns you are having only one thick mat underneath the structure, then you call this as a raft or mat foundation. I repeat, in case if the sum of area of all the footing that has been designed for the entire column of the structure is exceeding 50% of the total building area, then it is better to go for a raft or a mat foundation, which is a thick concrete bed underneath all the columns, which will be a single structure. In the next video, let us discuss about the various terminologies associated with the determination of bearing capacity of a shallow foundation. Thank you.